Hello student, today I will be telling you about the differential scanning calorimetry instrument, which is also known as DSC. So what is the principle of the DSC? So principle of DSC is a thermoanalytical technique in which the difference in the amount of heat required to increase the temperature of the sample and reference is measured as a function of temperature. So firstly I will be telling you about the what all is there in the instrument. So you can see here, this is our thermal analyzer, this is our flow controller, this is our main DSC instrument. So there are three parts, one is this and this and this, and one is the stabilizer. So this flow controller is connected with the nitrogen gas. So when the experiments are being done in the nitrogenous environment. So firstly, I will be now starting the instrument. So this is the main line, and this instrument needs to be on from the back. You can see when you will on this, you can see the power it will show. Also, it will show the temperature of the what is the temperature at that point. So you can see the room temperature is around 28 degrees Celsius. So you can see the temperature here. Now this is our flow controller. This is our thermal analyzer. It needs to be on as well from the back. This is already on. So you can see the green lights here. So now they are on. So this is connected with our PC. Now, for what we need to do first is we have to open the our cylinder. You can see, to pass the nitrogen gas. So now our nitrogen gas is flowing. So you can see here in the flow controller there are two things, 1 and 2. So this 1 and 2 show, the 1 and 2 is showing like there are two inlets for the gas. So currently it is joined with only one cylinder, which is of nitrogen. So you can see that the two light is on. So you can see at the back as well there are two inlets. So only one inlet is connected. One inlet is connected for nitrogen. So you can see the flow here. So now you will see that this will show you the flow in ml per minute. So when it is 100, then we are ready to operate. Okay. Now I will be telling you about how to keep our sample in the main DSC. So you can see this is our DSC instrument. Here there are two parts. Here at the top you can see there is a hole here. So this hole is used to keep the liquid nitrogen. So you know why do we need liquid nitrogen? So if we want to check for the range in negative temperature, like minus 100 degrees Celsius, minus to 120 degrees Celsius, we need to put the liquid nitrogen into this chamber, and so that will put the temperature in the range around minus 50 and minus 100 based on the sample. So yeah, I forgot to tell you, the range of the DSC is roughly around minus 180 degrees Celsius to, and it can go up to 1000 or 1200 degrees Celsius based on the instrument. So this instrument goes from minus 120 degree to 130 degrees Celsius to around 800 degrees Celsius. So now I will be keeping my sample into this. So you can see here, this is the removable part. You can remove this gently. Now you see here, this need to be taken out using this fork, and you need to keep this everything here. Now you see, just zoom in here. You see we have to take out this as well. So you see there are two places to keep the sample. Here we keep our reference sample, and here we keep the sample for which we want to do our DSC. So this is our PVA sample, polyvinyl alcohol sample, of which I have already shown you how to prepare the sample. So this sample needs to be keep here. We keep the sample here. Now this needs to be put back here, and then here. Now we need to close this as well. So now our instrument is ready to operate. So now I will show you the software which is attached to for the analysis of this experiment. So you can see there are two software. There is one software which is known as TA60WS. So if you can zoom in here, so this is the software. I will just click on the software. So you will see this window will pop up. Here they are showing the detector. So when this light is green, this is showing that our detector is ready. So when we will click on this, then we need to click on this. So when you will click on this, the new window will pop up. So now this is our main window. Here there are various options: file, view, measure, detector, analysis, windows, and help. So now, so just zoom in here. Here it is showing the time. Here it is showing the temperature. So current room temperature is 27.8 degrees Celsius. So it is showing the current room temperature. Now we need to click on this. We need to click on the measure. So now we need to put the measuring parameter for our sample. How we want to do it. So now this is our initial start temperature. So start temperature is 25 degrees Celsius. We can keep it like if you want to do it from like for your sample you want to check it from -100 or -50 or 50 or 300. You need to provide that temperature here. So the calculations will start from this temperature. So for our current sample polyvinyl alcohol, I'm starting it from 25 degrees Celsius, and I want to check it till 300 degrees Celsius. What are the changes that are occurring? So here we have given our start temperature. Here this you see rate and hold temperature. So it is showing a rate at which the temperature should rise. The temperature of the DSC should rise. So here, so Celsius per minute. So the temperature will rise at 5 degrees Celsius per minute. You can based on the sample time you can just change it. I will keep it 5. Now as I want to do it to 300 degrees Celsius, I will change this value to 300. So this is our whole temperature. And you can also provide like if you want to put it for at 300 degrees Celsius for 5 minutes, and then you again want to check it from 300 to some other temperature, you can just provide it in here. Now now we need to so this is all is done. Now we need to provide the sampling parameters. What are the parameters of our sample? So what this sampling time at what time at what second you want the measurements to be done, like 356.1 or 356 degrees Celsius, 357 degrees Celsius. So this is showing the sampling time. Now second is the third is the file information. We need to provide the file information of the file. Now it is asking for lot number, sample weight, molecular weight of our PVA, pan, what type of pan you are using, and what is the rate of flow of. Here we will put our lot number, let's say 1. Here we need to put the sample name. So sample name, as we are doing it polyvinyl alcohol, so we'll write polyvinyl alcohol. What is the weight of the sample? So as I've shown you in the sample preparation video as well, the amount of sample that is there in the pan needs to be put here. So as per our calculation, so it came around 11.3 milligram. So I put it here as well. And what is the molecular weight of the sample? So as we are doing for polyvinyl alcohol, for my sample, the molecular weight is around 26,000. So I will put it here. Now the pan is already aluminium. So there are different type of pans. Pan are there: platinum, aluminum, platinum, macro, stainless steel, quartz. So ours is aluminum. Atmosphere is nitrogen. Rate of flow is 100, as we have already told earlier. Operator. So now I will just click on OK. So now everything is done. Now just we need to click on the start. So when we click on the start, it will again ask for the file name. How do you want to say your file? So I will just say PVA on the date on which I am doing it. So today is 8th of September. I will put it here on the folder in which you want to put it, and then start. So the sound will come, and you will see here the controller will become blue in the pink. So you just saw that the background changed when we click on the start. Like, so that says that our measurements have started, and this here for 54 minutes is showing that how much time it will take to complete the whole measurement process. So this was all about the DSC experiment. After that, we will get the graph between delta H, time, whether delta H heat versus time, as well as temperature. So this is the whole thing. You can see here the temperature has started rising. It is now 30 degrees Celsius. So it will just keep on rising. Here it is. You can see the time is decreasing. Now it is 54.1 minutes. So this was all about the DSC instrument and how to operate that. I will just show you guys, as well as it will take 60 minutes. I will show you the already done file saved for different samples. I will show you. So this is one of the software is just called TA60. This is done for our sample analysis. So I will just click on this. I will just load some previously done file. So this is my MIP. I have done one of my batchmate has done for the 4.8. I will just open this. So you can see this. This is the general graph which we get for the DSC plot, which we get from the instrument. So the range of which was around 25 degrees Celsius to 200 degrees Celsius, and here you can see in the milliwatt it is showing the delta H. So there are various ways to analyze the data. You can just analyze the data on clicking on this analysis. You can temperature and time, DSC peak, where is the glass transition temperature is there, what is the peak height, and everything. You can just do it. Now here it is showing delta H versus time. You can provide the label, offset, and everything. So analysis part I will depends on the instrument, depends on the sample to sample. You need to do the analysis. So that I will not be covering in this. So thank you guys. This was all about the DSC instrument.